Hello everyone, and a warm welcome to Learning Ladder. Ever looked at the periodic table and felt a little overwhelmed? All those boxes, letters, and numbers can seem like a secret code. But what if I told you there's a simple, hidden map within it that splits almost everything into two major groups? Today, we're cracking that code. We're diving into the fascinating world of metals and non-metals. By the end of this video, you'll be able to look at the periodic table and instantly tell which is which, and you'll understand the key differences that make them so unique. Ready to climb the ladder of knowledge? Let's get started. So, let's pull up the periodic table. It looks complicated, but there's a neat little trick. See this zigzag line starting under boron and stepping down to the right. Think of this as the Great Divide. Almost everything to the left of this line is a metal. That's a huge chunk, right? From the alkali metals like sodium on the far left to the transition metals like iron and copper in the middle, all the way to elements like aluminum and tin. They dominate the periodic table. Now, look to the right of that zigzag line. This smaller section, plus hydrogen way over on the top left, is where you'll find the non-metals. This includes familiar elements like carbon, nitrogen, oxygen, and the noble gases like helium. It's that simple. Left for metals, right for non-metals. But what actually makes a metal a metal? Think about a piece of aluminum foil. What do you notice? It's shiny, right? This property is called luster. Metals are great at reflecting light. Now, try bending that foil. It doesn't shatter. It just changes shape. This is called malleability. You can hammer metals into thin sheets. They are also ductile, meaning you can stretch them into thin wires, like the copper wires in our electrical cords. Speaking of which, why do we use copper for wires? Because metals are excellent conductors of both electricity and heat. That's why your cooking pots are made of metal. They transfer heat from the stove to your food efficiently. These properties are all thanks to how their atoms are arranged and their electrons behave. But we'll save that for another episode. Now let's flip over to the other side of our zigzag line and talk about non-metals. They are pretty much the polar opposite of metals. Think about a piece of charcoal, which is mostly carbon. Is it shiny? Nope, it's dull. If you hit it with a hammer, does it bend? No way. It shatters into a bunch of little pieces. This is called being brittle. Non-metals are poor conductors of heat and electricity. You wouldn't want to make a frying pan out of sulfur, and you certainly wouldn't wire your house with plastic, which is made of non-metal elements. Many non-metals are even gases at room temperature, like the oxygen we breathe and the nitrogen that makes up most of our air. So, if metals are shiny, strong, and great conductors, non-metals are typically dull, brittle, and excellent insulators. But wait, what about the elements right along that zigzag line? Meet the metalloids or semi-met. These are the fence-sitters of the periodic table. They have properties that fall somewhere in between metals and non-metals. Take silicon, for example. It has a bit of a metallic luster, but it's brittle like a non-metal. The most interesting thing about metalloids is their ability to conduct electricity. They aren't great conductors like metals, nor are they insulators like non-metals. They are semiconductors. This unique property makes them the superstars of the electronics industry. The computer or phone you're watching this on is powered by silicon chips. These metalloids allow us to control the flow of electricity, which is the foundation of all modern technology. So let's recap. The periodic table has a handy zigzag line. To the left, you have the shiny, malleable and conductive metals. To the right, you find the dull, brittle and insulating nonmetals. And sitting right on the line are the metalloids, the versatile semiconductors that bridge the gap between the two worlds. See, the periodic table isn't so scary after all. It's a beautifully organized chart that tells a story about the building blocks of our universe. Thank you so much for joining us on Learning Ladder today. I hope you now see the periodic table in a whole new light. If you found this helpful, please hit that like button. And do not forget to subscribe and ring the bell so you won't miss our next adventure in learning. Got any questions? Drop them in the comments below. Until next time, keep climbing.